We're going to look at the series from 1 to infinity of minus 1 to the n times 2 to the 1 over n. We want to know if the series converges or diverges, and we'll be using the test for divergence. Now this test is often overlooked. Should always be tried first in almost every case just to see if we can determine that the series diverges. Here's what it says. It says that when we have a series, doesn't matter where we start, and if the limit as n goes to infinity of an is not 0, that could mean a finite number. A limit could be 5 or 1/4, or it could be undefined. As long as it's not 0, then our series diverges. And it's important also to know what the test for divergence does not say. So the test does not say that if this limit is 0, so limit n goes to infinity of an equals 0, the series converges. That is not true. What is true is if the limit is 0, the test is inconclusive. The series could diverge or could converge, but we can't conclude anything based on the limit being 0, and we have to try some other method. So let's return to the series here. This is summation from 1 to infinity of minus 1 to the n times 2 to the 1 over n. And we want to evaluate the limit as n goes to infinity of minus 1 to the n times 2 to the 1 over n. Now we'll break this up into a product of two limits. So the first limit is going to be the limit as n goes to infinity of minus 1 to the n times the limit n goes to infinity 2 to the 1 over n. Now first, the limit minus as n goes to infinity of minus 1 to the n does not exist. What happens is, depending on if n is even or odd, we either get minus 1 or 1 depending on even or odd n. So this limit doesn't exist. However, if the second limit were to go to 0, if the second limit was 0, it would pull the first limit towards 0 as well, because what we have is the first limit jumps between minus 1 and 1 as n becomes larger and larger. Nothing changes. Values become minus 1, 1, minus 1, 1. If the second limit is heading towards 0, it will pull the minus 1s towards 0 from the left. It'll pull the 1s towards 0 from the right. So it's important to look at the second limit. The second limit is not 0. As n goes to infinity, the exponent here goes to 0, but then 2 to the 0 goes to 1. So this is actually can be expressed simply as the limit n goes to infinity of minus 1 to the n, because the second limit is 1, and this limit does not exist. Well, does not exist means it's clearly not 0. And now we can use the test for divergence, because the limit is not 0, to conclude that the series from 1 to infinity minus 1 to the n times 2 to the 1 over n diverges by the test for divergence. So for more videos, visit www.mathprepvideos.com.